Hi everyone, welcome back. I'm Jason Baskin, and in this video I'm going to describe the process for creating a stretchy leg that scales with the rest of the character rig. You can see that I've got a stretchy leg set up for this character, but when I select the super mover and scale it up, the entire leg setup breaks. So we're going to talk about why that happens, and I'll show you how to fix it in this video. If you haven't already watched the other videos describing the stretchy leg setup process, you'll want to check those out. This setup is based on the utility node setup. You can see I've got a couple locators that are feeding into a measurement or distance dimension node. And then the distance value from that node is feeding into two more nodes. One of them is a condition node, and one of them is a multiply divide node. The multiply divide node is dividing the current measurement by a maximum value for the leg. And then the stretch condition node is taking that normalized value and using it to scale the joints if the current value is greater than the maximum value for the leg. So we're actually going to simplify this setup just a little bit before moving forward. Rather than feeding this distance value into both the multiply divide and the conditional node, I'm just going to use the value from my multiply divide node, my normalized value, to evaluate whether the leg should be stretching. So I'm going to break this connection just by selecting the arrow and hitting delete. Then I'm going to take my output x from my leg normalized multiply divide node, and I'm going to feed it into the first term of my stretch condition. So there it is, that's the normalized value. And then I'll be able to change my second term to 1. So this is just a little bit more streamlined. It's doing the same thing as before, still stretching just as before, but I don't have to feed that measurement value into both of these nodes. I'm just feeding it into the normalized multiply divide node. So the reason that this stretchy leg setup breaks when I scale the super mover is because I'm not dynamically updating this maximum distance when I scale the rig. So you can see if I select the super mover and scale the rig up, the maximum distance hasn't changed, but the measurement has. So this setup is working under the assumption that because this measurement value is greater than my max value, that this leg needs to stretch, but of course it doesn't. So what we need to do is we need to modify this maximum value to dynamically reflect what the scale of the rig is. So I'm going to restore this back to its initial scale of 1. And then I'm going to create one more multiply divide node. I'll right click and choose create node. And then I'll type in mult, which will bring up a list of utility nodes that I could use. I'll click on the multiply divide node. And here's that new node. And I'm going to call this new node scale compensate. So this is going to compensate for the scaling of my super mover. So then I'm going to look at my maximum value for my leg normalized node, which is 8.389. And I'm going to copy that. I'm going to paste it here into my scale compensate node. I'll just paste it right here next to input 1x. So this multiply divide node is set to multiply. So if I'm taking that value and multiplying it by 1, of course I'm going to get 8.389. I'm going to feed the output of this multiply divide node, the output x, into the input 2x section of my leg normalized node. Remember, this was a constant value before, but now it's changing based on the result of this multiply divide node. 8.389 times 1 gives us 8.389. And then in order to connect this to the scale of the super mover, I'm going to change this value from my scale compensate node to match the scale of the super mover. So when the super mover is scaled to 2, this number is going to double. When the super mover is scaled to 0.5, this number is going to be cut in half. So I'm just going to use the connection editor to make that connection. I'll go to Window, General Editor's Connection Editor, and I'm going to connect one of my super mover values. It could be any of these because this is really based on the assumption that the scale of the rig is going to be uniform. So I'll just take my scale x value from my super mover, and I'm going to feed it into my input 2x for my scale compensate node. So I'm going to load the scale compensate node on the right here, connect the scale x of my super mover to the input 2x of the scale compensate multiply divide node. I'll close the connection editor. And now you can see that the rig holds together properly when I'm scaling it, but I still have stretchy leg functionality active on the rig. So whenever you have a stretchy leg setup, you're going to need